Welcome, 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 everybody, to this week's Tish Talks Tech. I'm your host, 𝗪𝗂𝗪, and I have with me Jack War, IBM champion, and just amazing mind of our time. I cannot believe that we were able to have Jack with us on our show. Welcome, Jack. Thank you so much for coming and being with us. Thank you, thank you, thank you. How are you today?
I'm fine. I've been out shoveling snow. I live in Colorado. So,
Snow is a thing right now. Listen, I know that our time is limited. We only have 59 minutes, and it is uh, uh, going to be jam packed. I want to be the first to say thank you for your contributions to our space, to tech, period. Not just mainframe, not just quantum, not just IBMI, not just IBM-Q, just like everything, because you are one of our great thinkers. Um, do you mind introducing yourself and letting us know just a little bit more about you? Because there's so much to learn.
well, I don't know what to say after that buildup, but
You know how I
you're
get.
very kind. I do appreciate you are a very supportive person in the community, and
Thank you.
I think it's important that we all feel good about the business that we're in because some folks in the programming community don't understand what we do, and they think we're old fuddy-duddies, and they don't necessarily appreciate what Byron, I believe it's Byron Smith, has pointed out that um, 90% of the world's commerce runs on these, big systems that we deal with: IBMI, IBM-Z, and a mixture of some other ones. But these old computers that are really quite modern that we are engaged in operating and programming are the backbone of world trade.
Mm,
Well, and I didn't start there. I'm not, like, I didn't come from originally the IBM world exactly, though it's kind of funny. The IBM's always been there for me. IBM was a customer of mine when I was back programming little embedded control computers, and that's where I started.
hmm.
I thought I was going to change the world with, multilingual word processors. When I started programming, that was what I was kind of interested in. But like all of us, I followed the trail of breadcrumbs from, assignment to assignment. And what I really ended up working in was embedded control, a wheel balancer, a little device to sit in Thule, Greenland and measure the temperature and the rainfall. Then IBM came along, a device to ride along inside a Freon bath when circuit boards went inside a Freon bath to get cleaned up after making and come out and see what happened to them inside the Freon bath.
Oh,
A
wow.
little accelerometer that rode along with packages on one of the major shipping companies and bounced around and told whether tattled on whether the driver was tossing it off the loading dock because it could tell from the accelerations how the package was being treated.
Really?
Yeah, it's kind of, yeah. So, I started in bank control and microcode because at the time, in the late 70s and early 80s, the processors, uh, a lot of the things that are architecturally decided now
Hmm.
in computing were not architecturally decided. Mainframes were very stable and were progressing in a given direction and just getting better and better at what they did. And internally, the architecture of IBM-Z systems changed, but they were called the 370, then the 390, then the 3090, then the Z series in terms of the mainframes, and then in the IBM-I world, which is where a lot of my practice is now, most of my practice. You had the system 34, 38, and then 36, 38, and
Hmm.
then then the AS400, and then the I series and IBM-I on the power systems. But I won, I started in embedded control, and I became, I would write the entire operating system for the board. We were running in like 64K of memory, and 32K of memory was the operating system, and 32K of memory was the application.
Oh, wow.
And we wrote our own operating system in a language called Forth, which had a specific, which was very efficient in terms of memory usage, and also had a specific approach to it, which has followed me all through my career, an attitude towards simplicity and directness, which I believe is very important. And then I began programming Unix systems, and VMS, VAX VMS, and I taught myself C on a VAX VMS machine, and at the University of Washington, and I got involved with programming desktop computers. I was an early contributor to Microsoft NT. I was in the developer program, and I wrote a Forth system, that language Forth, that was written in assembly code. And Microsoft said, "You did what? You wrote a whole program in assembly code on Windows NT?" I said, "Yeah, here it is." And so for years,
there you go.
Yeah, right. Yeah. And it was open source, because I was in the open source community already. Because when I started,
Wow.
everything was open source. Closed source happened when the PCs came in. Mainframe operating systems and VAX VMS, these were delivered at, both in binary form, but in source code, because there wasn't this big internet infrastructure. There was DECnet and there was VNet for IBM, but it was not practical for, people. They didn't have easy automated ways to turn in reports on defects. They'd get on the phone with IBM, say, and they say, "I've got this problem," and they'd talk over the phone, and they'd say, "Well, make this change to the source code and recompile the kernel of VM."
Yeah.
And they would do that, So the source was there because it had to be there.
Right.
And and the Lisp machines that Richard M. Stallman of the Free Software Foundation was working on, they all came with source. And when the PC came in, this idea that, and the machines that preceded it, the CPM and TRS-DOS, little machines that were around at the end of the 70s and early 80s, they had closed source. And so when we say open source, it's kind of like we're saying, hey, where did it all go? Where did the source go? You're hiding the source from us. When did this start? So open source, free software, that idea grew out of the fact that all source had been open. We distributed code in source. We distributed programs in source code. So I was part of the open source community. So I wrote an open source Forth, and they put it on the first freeware disk for Microsoft NT. And then, in my usual way of going backwards all the time, I then went to OS2, which was a little older than NT and was, to me, much more satisfactory. Windows NT. I was very much happier with OS2, and then OS2 kind of, I developed in OS2 as a contractor at IBM in Boulder, Colorado, and I became very involved with the IBM. It's funny. It's very, anyone who works at IBM will tell you sometimes it's very difficult to work at IBM. There's a lot of pressure. It's a big organization. There's a lot of weight on your shoulders of holding up this big blue tower that is IBM. And it was very difficult for me, but every day I would drive into the parking lot and I would say, "Man, I'm working at IBM." It's just so pleasurable to me, even though every day there was one more thing, One day at IBM in Boulder, they were working on the roof, and the roof broke, and gravel from the roof repairs fell on my head as I was sitting at my computer, to give you an example of what I went through at IBM. But that was, all sorts of weird things. But, I developed an OS2, and with the OCL, the Open Class Library, which was related to what shortly thereafter became, it was related to Taligent and Pink and what became the AWT, the abstract windowing toolkit of Java. This was all an effort that was taking place between Apple and Sun and IBM at the time. And so a lot of the ideas, I was there in the middle of this ferment about visual class libraries. I was using,
You were a part of that?
well, I was one of the guys who called Toronto and complained about the class library when it didn't work. You know, I was part of it to the extent that I was certainly an early adopter, because IBM was a great believer in what we used to call eating your own dog food, which is if we produce it, we'll use it.
I love this. Keep going.
Yeah. And then after 4 years contracting around IBM, I did other things, and I had gotten involved with. That's when I got involved with mainframes. I was at IBM, and we got our mail on the mainframe. We had to log into VM to get our mail. And I thought they were kidding me when I first, because there were modern email systems. I was already using email systems on Windows and OS2, using email in the browser and stuff. This is the early 90s. And that was already there, that you could have, the email thing. But
Right.
the browsers came a little bit, 93, the browser shows up.
Right.
But email, I was, very familiar with getting email online on Unix systems. Mm-hmm. And then all of a sudden I'm using this weird green screen terminal. I said, what is this? And so like a lot of time I was supposed to be doing other stuff with OS2. I'm sitting there like playing with the mainframe. What is this? And suddenly I understand how they're programmed. These are like giant machines with all the memory you could imagine, networked to every computer in the world at a time when, I had internet via Unix, but the networking, the speed of the networking on these boxes was incredible for me at the time. Mm-hmm. And they're programmed in assembly code like an embedded controller, like where I started. And I said, oh, wow, like assembly was still basically the most important language on the thing, that and Rex. And I already knew Rex. I'd run into Rex already on the Amiga in the 1980s. And so I started playing with the mainframes. And then I understood, as I looked at how assembly worked, I saw the macro libraries. And I looked at this and I said, this was the oldest code I'd ever seen in my life. I mean, in my short career, this code had been, these macros had been written in the 1960s. There was just this incredibly, I'd never seen 30-year-old code before. I had never seen that. And I said, wow, this is mature. This is debugged. I've been living in this world that's basically, nothing happened before yesterday. We were all born yesterday.
Right.
And all of a sudden I'm looking at 30-year-old code, and I became very, it was a profound change in my understanding of computers, of computer programming, that code did mature and that it could stay and it could be useful for that long. And that's one of the marvels of the mainframe world, is that we still use code that was written by people who are not only retired, but they have gone on to the great green glass house in the sky. And, so this stuck with me. So I got engaged with VM 390 and OS 390, which had been brought out, which was the wedding of MVS with USS, the Unix System Services. Mm-hmm. And that was fascinating. I said, oh, they've married Unix to the legacy operating systems. And I thought that was fascinating. Right. And I went on, and then my next job, I suddenly was involved with IBM with AS400.
Okay.
And SNA net. Well, of course, I'd encountered SNA networking inside IBM. Mm-hmm. And then I got to see, SNA networking in IBM in AS400 at the time. And I wandered on to some other things after that in the early 2000s, but I kept access to IBM and I kept access to ZVM and ZOS. And the late Dave Jones was very helpful. I don't know if you knew Dave Jones, but he was an IBM champion, and he just passed away last year, unexpectedly. He was gone, Oh, wow. And had a stroke and was gone. Mm-hmm. And he was pretty young. And
I'm sorry to hear that.
He was a pillar of the community. He was an answer man. He was always helpful, and he always helped people like me who had intermittent professional access to the Z architecture. And he had the ZPDT boxes, which are the Linux-based emulator boxes that allow you to program ZVM and ZOS at home, or in your private business, because it's a little bit more expensive than a home thing. It's
Right.
it's over $5,000 for that kind of setup, but it's not really. It's much less. It's much cheaper than buying a mainframe. So
Yeah.
so he was developing, and he would give me access, and I happily was writing open source stuff for ZVM, even though I didn't have at the time professional access to ZVM. And at the same time, he didn't work with IBMI, but I had found public access, and I was paying at the time for paid public access to IBMI, so I could keep writing for that and keep my hand in. And I was working in at the time I was working in things like Solaris and in C++ and Solaris, and then I was working in J2EE, Java, and I'm still there banging away on the mainframes and on IBMI. And then I transitioned over time as I was working for an MSP, and I kept saying, "Do we service IBMI?" And they said no. I said, "Well, why not?" "Well, we've never done it before." "Okay, well, here I am. Find a customer." And they found a customer. And so then I was, bam, I was IBMI, the IBMI for that company. That was it. It was Jack,
Yeah.
So that was, the baptism of fire. I asked for it and I got it. Be careful what you wish for. And I'm there in the middle of the night learning from the manuals how to install the operating system on a machine in the cloud, and
Here you go.
Jack, we sold this. You've got to finish this.
Yeah, of course. But why not? Why not? It feels good, right?
Yeah, it was. Failure was not an option. And of course, as we all know, and as we understand and appreciate better and better as we get older, it takes a village. When I went through some of my episodes, I would not have still been employed if it hadn't been for the people on the net who are there 24 hours a day, sleepless like I am, just answering questions in the mailing lists and stuff like that. And so, and I was one of those people for what I knew. And for the things I didn't know, there were the other people like that. Rob Barrett, IBM champion, Rob Barrett, was a very big help to me in IBMI. And it takes a village. It definitely does. And that's another remarkable thing as I became more and more professionally, deeply, full-time involved in the bigger iron, the mid-range and the mainframes. And then in the middle of this, I suddenly spent 2 years working with OS 3.9, ZOS again, and VM. Had some customers, private. I'm an independent consultant, so I was working for this MSP, but as a contractor. And so I would also take some contracts on the side. So I took some ZOS and some ZVM and worked on them. And the deeper and deeper I got into our community, the more I realized that it was a much tighter community than you generally see in programming. There are little niches, like if you go to the Apache Foundation, there's people who are Apache nerds and they hang around Apache and work on Apache projects. But there's so many of them, and they work off in different places. Or you go into Vue.js and there's Vue.js nerds, or you go into React and there's React nerds, and there's isolated little communities, each one of whom probably have as many members as the whole big iron community has.
Right.
But we do so much in so many different directions, and there's a small number of us really compared to the rest of the programming community, and yet and we're so productive that you see a shop, you'll see a big company making billions of dollars a year, and they'll have 5 people working on on the mainframe side of things or on the IBMI side of things, and we carry so much on our shoulders, and we're a small community, and we help each other a lot, and we're in contact all day, and it's a wonderful community to be part of.
Right. That's my whole thing. Like I wish that folks knew just how tight knit champions are. The community is on a whole. because everybody, pretty much almost everybody knows everybody, and we know what each other does, and it's so easy to just tap somebody on the shoulder and say, "Hey, you know what? I need help with this," or "Do you know somebody that does that?" And they will be able to easily come out and help. Whether it be virtually or when you see them at the next conference. So yeah, I love what you stated. And can we just wrap our minds around the willingness and the eagerness to learn things? What you did with IBMI, I don't think that, well, there's a lot of folks that do work within IBMI, but the leaps and bounds that you created within IBMI, just for what you did in your scope, that's remarkable. Can you tell the people that are brand new to technology, brand new to the platform, to Z, what is that process? What does that process look like when you're learning and you're on your own learning? When you're independently learning, because you have badges that you've done, you've reached out within the community. What does that look like?
Well, when I started, it was not clear to the whole world that technology, that programming, software development was a career path. Not everyone perceived that. And the people who got into it were self-motivated, and they did it because it clicked with something in their nature. Mm. And if it clicks within your nature, you become one of the important people in the community. And you realize after a while that what your job really is constantly learning, because the ground is slipping away under your feet at all times.
Wow.
It's like the Red Queen said in Alice Through the Looking Glass. You've got to run much faster than that just to stay in one place.
I love it.
Yeah. And so we're all in that position. So I've been doing this for 40 plus years, and I'm constantly learning new stuff. So if you're just coming into the community and say, "I've got so much to learn," okay, I'm over 70. I've got so much to learn. I'm still in the same position. It never changes. It never changes. So don't feel bad about it. It's just, that's what you're doing. You're being paid to learn. Yeah. And you just go out and you learn it any way you have to. And it is very easy now, because it's all on the internet, and you have access to it while you're riding in the trolley car in Denver to the Denver Tech Center or whatever. You've got your phone as your Wi-Fi hotspot. You're sitting there and you're looking this stuff up, and you're programming on your laptop as you ride to work. Yeah. Whatever. And you just do that. So if you want to, it's all out there. And the more you understand of how it works, I am surprised. I'm surprised, but I shouldn't be, but I do interview people for jobs. I help clients find, candidates, new entry-level candidates. And a lot of them come out of school for programming. And I always ask them, and by the way, do you know how a computer works electrically? And 9 out of 10 do not nowadays. And that was impossible when I started, because the computers didn't work so well. You were always there with an oscilloscope and a soldering iron.
Yeah.
Nowadays, you can use computers, and this, I started meeting people like this in the 1990s. You can operate a computer without knowing how it works. And the more you know about how it really works, the more easy life will be for you as a developer. And when you get into the mainframe community, and when you get into the IBMI community, you tend to know a little more than most people do about how the things work, because in the business we're in, moving big data, we're at the edge where quantity becomes quality. So to move all this data, you have to be very aware of the limitations of the hardware. You can't sit there in your cubicle and say, "It doesn't run fast enough. We'll tell the boss to buy a faster machine." You can't do that in the mainframe. The machine was bought on a capital expenditure program that was planned 10 or 15 years ago. and you've got this much hardware, and it's got this many network cards, and you have to become aware. And they're on 24/7, and they fail, and you call the field engineer, and he says power it down, and you're there as the system operator, and you power it down. He pulls it out, hot swaps it. He says power it up. So you're constantly, and it's not just, oh well, I've got the coolest GPU I just put into my PC. That's easy.
Right.
You turn the PC off, you put a GPU in, you turn it on, it loads the drivers. Well, something like that happens in the mainframes too, but you have to understand it at a more profound level, how all this stuff works. So, for the new people coming in, it's all there. You have to learn, you have to learn the holy books of our religion. You have to learn how to read IBM documentation, which is an art in itself.
Thank you for saying that. Can I just say, I was talking to a group of students just the other day, and I was saying, you have to know how. It's not just knowing where the information is, you have to know how to read it. It's very important to understand how to read that documentation, because you can read it today and it means one thing, but you can read it after you've done the task and it will mean something completely different. Could you please sprinkle in your wisdom, Jack, on what that actually means from your perspective?
Well, I discovered when I was contracting at IBM, and before that, as I said, I had IBM as a client, and this is how it was to deal with IBM as a client. When I was doing embedded control, I told you I had to dip something in Freon and take it out. Embedded control rode along with it and saw what was happening in the Freon bath. They don't use Freon anymore. This is, but that was how they used to clean circuit boards. They'd make circuit boards, they'd dip them in Freon and then take them out, and et cetera. So an elderly fellow came from IBM, and he had an 18-page specification in his hand, and he said, program this, and he laid it on the desk. Yep. And he came back 2 weeks later, and I gave him his program. And he disappeared for about a month, and he came back and he said, you did everything correctly. We were wrong. Here's the new spec. Please correct it to match the new spec. And I did that, and he took it away, and they paid their bill. And that is how this stuff was designed, and it does what the specification says it does, and it may do things the specification doesn't say it does, but don't ever count on it. Because IBM is the original top-down shop. And so when you deal with IBM software, it's changed a little bit. It's more like, the way it works, on the wild, it's like quick start, here, give me the quick start. I don't care about the details. Just give me the quick start. Let me get started. They have those in IBM nowadays. Yeah. But the culture, like Ice 9 in Cat's Cradle by Kurt Vonnegut, the culture is like a set of crystals that keep reproducing themselves over and over again across the years. Yeah. IBMers nowadays, they say, well, we're nothing like the IBM of 40 years ago. I said, no, you're exactly like it. You just wear different clothes and your hair different, and you have tattoos now and piercings and stuff, cool. Which they didn't. Yeah, you're cool, but you're still recognized. If you went back in a time machine, they'd look at your clothes and wonder. But the way you think, the combination of incredible productive technical skills plus a focus on the business case, that's what makes an IBMer. And it's a very hard discipline, and only a certain number of people can be an IBMer in the world. Yeah. And so when IBM writes documentation, they mean what it says. And if it doesn't say the right thing, you immediately get in touch with them and they change the documentation. But you have the underlying assumption when you deal with these complex systems that carry, billions of dollars of business every day, is that you are, as we used to say in the Unix world, RTFM, you read the fine manual, and that you read it and understand it before you take responsibility for operating the system. If you are dealing with IBM security, you take at least a pretty good look at the 1,002-page IBM security manual. Now, you don't have to read every word of it, but you should read the section headings, and you should look in certain sections very deeply and read every word that's there and work through every example.
Yeah.
So you really do have to pay attention, because that's kind of it's a slightly different mentality that shaped this whole culture. We were expected to be very, very professional, and we're expected to understand what we did before we do it. When
Yeah.
I first got involved with mainframe programming, I was surprised at its mainframe programmers seemed to me to be somewhat less productive than PC programmers. And what it was is there was a lot more to think about before they changed a line of code.
You can
So
change the entire world if
yes,
you change the line of code.
as I learned the first time I wrote a mail loop on a VM mainframe, you'd be amazed how many mail messages a VM mainframe can send to itself in a few seconds. I wrote a mail loop by accident. I was allowed to configure the email system. They trusted me with that, and the trust may have been misplaced at that time. But the compensation for it, and now I want to say that, like, the most important thing, as all of us know right now, is for young people to come in and join us playing with these big machines.
Yeah.
And there's a lot of rewards. And I've had young people say, "Wasn't it boring?" And I say, no, it's not like programming video games. It's not that kind of exciting. You know what I mean? If you like video games, you want to program video games, go program video games, but they won't pay you for that because everybody wants to program video games. So you'll be working for peanuts.
There you
You
go.
work in the mainframe field, you get a pretty good salary because it's very serious work.
Right.
And within 5 years, you're reporting to the CIO, because there's a small herd of us that maintain this stuff, and you can advance very quickly in this field. The compensation, though, the technical compensation, if you really are a nerd, and I confess, to being a nerd, that people have said to me, "Isn't it boring?" And the answer is no, because it's like those liqueurs that have a different color at every layer up the glass. There is so much more in legacy systems programming, and I'm not ashamed of the word legacy. A legacy is something valuable that's left to you by your elders.
Right.
A legacy system, it may be encumbered with debt, like if somebody gives you a real beautiful house that the roof's falling in, but
or the plumbing needs fixing.
Plumbing needs fixing, but it still has value.
Yeah.
The legacy system programming, you have to know, they have all the modern stuff. They have all the modern stuff. They have Ruby, they have Perl, they have PHP, they have Node, they have Java, they have Python, and they're in use and they're important, and secure shell and SCP and SFTP and all the things. There's these legacy systems all have this Unix side, and they have the legacy side, and they interoperate, and each one can call the other back and forth. And nowadays, our practice is involved writing a lot of stuff that works exactly that way. The two sides talk to each other, and half of what you're doing is on the one side and half is on the other. So every skill you already have is useful in the mainframe world. If you're coming from like a web boot camp where they taught you basically how to use a Unix shell, and they taught you how a server works, and they taught you Node.js. This stuff is very useful, and you're welcome in our community. But while you're there, you're going to learn everything that's happened in the computing world for the last 50, 60 years. I have seen code in my professional practice that was written in 1968. That's how far, it's like there's older stuff than that floating around out there. It's not that it's the whole thing, but somewhere at the bottom, there's this little piece that was written in the 1960s. And you really have to kind of get to understand this, to really understand what you're doing in these systems. That's fascinating. It's like some people like to build, some people like to build backyard sheds. Some people like to build their own house, and some people like to build skyscrapers. And we're in the skyscraper business. That's who we are.
Right.
To our communities. If you want to come in and be apprenticed to a small group of people who know how to build skyscrapers, and these things really are skyscrapers. It's amazing how much they do in our world of international trade. It's amazing how much is on the shoulders. Every time you buy an airplane ticket, if you're on the biggest airlines, you're talking to at the end of it, doesn't matter if it came in through Travelocity, you're talking to a mainframe.
Yeah.
So this stuff is, there was some kind of idea that J2EE was going to replace TPF. TPF is our transaction processing facility, which was originally called the Airline Control Program, ACP.
Ooh, talk that talk, Jack.
Yeah,
talk
well, it was decided. Somebody was at a cocktail party, and like I think it was the president of Eastern Airlines. This is all folklore, but it's written down somewhere. And I probably had the airline wrong, and I've got everything wrong. But basically, I think the president the president of Eastern Airlines was at a cocktail party with an IBM guy, and he said, IBM exec, and he said, you know how we sell airline tickets? We have people in rooms with whiteboards and marking pens, and people on the phone shouting at them, and they're sitting there crossing out the seats as they're sold. That's how we sell. This is 1960s. That's how we sell airline tickets. You've automated our payroll. Can't you automate that? And ACP was born. It became TPF, and it's used for a lot of different things. Yeah. And they have conventions, like everybody else. The TPF programmers have conventions. And, that's just one little corner of the mainframe world. The idea that, every airline ticket in America, that's one little corner of the mainframe world. It's much bigger than that. It's a much bigger world than that. So no, it's not boring. It's very interesting. And you suddenly learn how this crazy world we live in works if you work with the big iron. You suddenly, how insurance works, how banks work, how airlines work, how trading companies work. Because there was some kind of idea that J2EE was going to replace, Java J2EE was going to be the transaction system, was going to replace TPF. And from my point of view, and this is just Jack talking, this is not authoritative. It appears to me that, Sun Microsystems sort of bet the store on that, and it didn't happen. I mean, J2EE was used a lot, but it didn't become the transaction system of reference, which TPF and KICS, another system, CICS, KICS, still are, because they run their systems that were written a long time ago and have been maintained and improved, but they're kind of funny, because they were actually designed a long time ago.
Right.
Funny old systems are the systems for transactions that run on the fastest business machines in the world, which are the IBM mainframes. And because of that, they just can't be bumped out of the way, because they run on the fastest hardware there is, and they're very efficient on that hardware. So even though they're crazy by modern standards, they look they're really well designed. They aren't that crazy if you've watched these things evolve. It's just the terminology is always unique, and they don't use the same terms for things. But after you understand how they work, I was just brushing up my TPF skills, taking some free IBM learning. They've got some great
free 99?
Free. Yeah. Yeah. So they just came out with a couple new TPF courses in the last year or so. And I said, oh, well, I didn't know much about TPF. I was working around it, but I didn't, really dive into TPF. Right. And I looked at it and I said, oh, this looks like the way TPF works is fabulously efficient transaction processing system, very, 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 very reliable, that runs on the mainframes. Oh, it's its own operating system, basically. And people don't know what, there's a couple of these things like KICS and TPF that are almost like their own operating systems. And I finally understood how it worked, taking these beautiful new courses that are on IBM, learning. Mm-hmm. And there were two of them. And they were very, the test was very difficult to get the badge, Right. But when I finally understood, I said, well, oh, this is like the super efficient kernels that did both cooperative round robin tasking, where the task yields the processor. At the same time, there's an interrupt driven thing. So if they don't yield, something takes care of it, and they yield whether they wanted to or not. And I was writing stuff like this for little embedded controller boards, back in the 1980s. It works the same way, except that it works on a piece of computing that costs $5 million. Yeah. So it's like, wow, this makes perfect sense to me. It's like, when you get down to it, if you're not looking for frills, if you're not worried about scroll bars, you know,
Okay.
and the shape of the widgets at the edge of the screen. If what you're really
Right.
thinking about is how does the kernel work and how does it efficiently serve things,
Right.
well, the rules haven't changed since computers were invented. They really haven't changed. And all of a sudden you get involved in this world and you suddenly understand, oh, at the bottom, this is how all computers work. This is how Unix works. You know, again, the tasking and the saving the registers and all this stuff. And you understand computing better. And it's easier to see in the mainframe words sometimes because you're so isolated from all this now, because so much of the practice in desktop programming and in web programming is about the presentation layer. And about, you know, and you do access to the database, but you don't have to know how a database works. You just have to know an SQL query, and you feed it into it in JSON, and it comes back, you know.
Yeah.
And so you're way up there, way up at the top of this ocean of creativity that took millions of people, that was developed over the last 60, 70 years. Whereas you get into the IBM world and you deal with these business computers, and all of a sudden you get a real close look at it. It's like the Visible Man, you know, that little toy that used to be able to see the you know, plastic man with the guts.
Right, with this stuff on the inside. Yeah.
Yeah, right. The mainframe and IBM systems are very visible on the inside because if you want to add a presentation layer to it, you do by adding by adding an API and putting a web application talks to the API. The mainframes don't deal with the visual presentation. They just are the computing. They are the computing power, the big computing power. And suddenly you're staring right into that furnace, that giant nuclear furnace that is real computing power.
Right.
You suddenly understand how it works. And if you decide you don't want to work there and you go back and you go into, you know, you go off into some, you know, game programming or web programming, you're a much better programmer for having been there because you see how computing works.
Right.
You know, how computing hardware works. And
right.
It's really beneficial to your practice, no matter what you do in the rest of your career. And if you're young, you can't make a wrong decision as long as you got a paycheck. Anything you're working on will help you. It's impossible to get the wrong job. You know, you can't get the wrong job unless they're abusive to you. That's a different story. But I mean, in terms of whatever, it doesn't matter what technology you're working on. If you say, oh, I'm working in this and I'd rather be working that, don't worry about it. You got a long career ahead of you, kid.
That's it.
Don't worry about it. Just learn what you're learning and learn how it works. And if it stops doing anything for you, if you stop learning, you're in the wrong place, and maybe it's time to brush up the res.
Right. So, Jack, what about with the little bit of time we have left? What about mentors? What does one do to find mentors? Is a mentor important for people coming on?
Well, if you're coming on, I think you will find, first of all, hopefully, the people who are there who've been there a while are going to be willing to help you. Secondly, there's user groups for all these platforms, multiple user groups. There's separate there's multiple user groups. There's groups for the platform, groups for the particular applications / operating systems, like, you know, basically TPF and Kix sort of run under ZOS, but like if you want to know Kix, there's support groups for Kix and there's support groups for ZOS, and they're separate. And you just participate, and the learning online gets better and better. IBM's really working on that. Interskill is working on it. Jim Buck at Empower Technologies for IBM is working on it. Lots of people are working very hard on making sure that the next generation can come into this practice. There are mailing lists. It's strangely enough, you know, mailing lists are more, we have Discord groups. There are Discord groups for these platforms, and they tend to mostly be young people with, you know, some old dudes like me hanging out. And, you know, so there's Discord groups for ZOS, for Z Systems, for IBM. There's Slack channels, there's mailing lists, there's people who are interested. I teach a class in IBM once a month. It's on Meetup. And we just talk about whatever people are in. It's not a programmed course. It's just, you know, whoever shows up, you know, what do you want to know? Well, okay, we'll do this week. We'll play with this. With
their interests, yeah.
And our tool chain is you know, what's really happening now in the mainframe and the IBM world is we're turning everything, the legacy code, into, we're putting API faces on it, and we're writing web applications either on the platform or off the platform, calling into the APIs. So you go into one of these shops, and if you know web programming, you can be immediately productive without knowing anything
Mm-hmm.
about the platform. All you have to know is the API calls, because we're just, of course, there's some web applications that were in a few years ago and they actually do ODBC directly, or they do something else crazy and they talk to the platform at a lower level than it being all packaged up in an API. But basically, we're in the open API world now, in the
Yeah.
mainframe world. We're in the open API world where we give you the specification for the APIs in Swagger documents, just like you'd get in any other shop. You don't even have to know it's a mainframe. It's just an API machine,
Right.
and and it's answering you, and then you begin to dive in deeper if you want to know. And you will be asked to learn more, because you'll be taking more and more responsibility. And suddenly you find that you're a full stack developer, and full stack developer means something much deeper in the mainframe world. Okay, so here's you in the web application. Here's the API. Here's the Swagger document. Then there's an API connector, and then there's the API translator that's underneath that. And then underneath that, there's something called Kix, or there's something called TPF, or there's something called IMS, or there's something called DB2, and then you get to learn that whole rigmarole. And within 20 years, you're pretty familiar with all this stuff. But it's a career. It's a career, and if you like it and if you stay, you never run out of stuff to learn, because it's big, and it's like you're trying to memorize all the it's like Notre Dame Cathedral. There's a lot of rooms in the place.
Yeah, and we're not afraid of the trial by fire, and we're not afraid of writing things down.
Right. So, and you're welcome. I mean, this world is pleading for young people to become involved, and you're very welcome. And you may find a few crusty old timers who won't give you the time of day. It does happen.
Gotta be crusty, Jack.
It does happen, but it's not me, and it's not most of the people I know.
Definitely not you. It's definitely not you.
And everybody's glad to help you. And if you get to know people on the mailing lists and stuff, they'll help you, adjust to it. And there's training, and people, your boss will send you to training because they have to.
True. That's true. In order to get you nice and productive in production, you got to be able to produce. And the only way to do that is to go to training.
That's right.
And so I guess I want everyone to understand that you are a real person. You actually are not a machine. Contrary to popular belief, you were not built by AI.
Right. No, I'm a real person.
You're a real person.
I'm a granddad.
You're a granddad. You play music.
Mm-hmm.
You have animals that walk through your yard.
Yes, I live in the mountains. I live in the mountains in Beulah, Colorado. So.
Do you mind telling us about the music that you play?
Well, on my mother's side, I come from multi-generational family musicians, and so I was playing piano by the time I was 4, badly, and I've continued to play various musical instruments badly my whole life and sing badly. And I've played in groups, and I've actually recorded with with 1 or 2 Grammy Award winners over the time. In my non-career in music, it's amazing. Music is another place where it's easy to get in if you don't expect to get paid.
Okay.
And I have lots of friends who are fairly prominent in the music industry, and nowadays I still play, I still perform. We have a festival in Beulah every summer, and I'm the MC and I perform. And I do a certain amount of performing with Hawaiian bands. I lived in Hawaii for a while when I was younger, in my 20s. And so, I can sing in Hawaiian, and I play upright bass, or I play guitar, or I play ukulele for these bands.
Mm-hmm.
And there's a fairly, organized Polynesian community in Colorado, and it's a very warm and inclusive community, and I enjoy that very much.
I love it. And do you cook as well?
No, no. My wife cooks. We stay out of each other's way. I do dishes. My wife's a potter. People ask me, "Are you a potter too?" I say, "No. I pick up 50-pound boxes of clay and take them into the car and out of the car."
Right.
You know, that's and I provide her with IT services here because there's no business that doesn't need IT services now.
That's
So I'm the IT department of her pottery business, and she's the cooking department of the family unit.
right, right. Okay. Yeah, I remember those stories you were telling me about being the IT department. I thought that they were just adorable. Um, now I do have some folks over here in chat, and we'll start with David S. And David S was saying, let's see, yeah, OS2, I still want a Model 95 last of the line.
Yeah, right, right there. Fine. Yeah, 300. The last was a 350 megahertz processor, and
Wow.
it was amazing what you could do with them. They could do speech recognition on those.
Oh,
Yes, I was on late at night, and the OS2 came when OS2 started shipping with speech recognition. They had a little test application where you named a state and it lit up red on the map of the United States. And I was on the night shift, and somebody from Australia who was working daytime said, I can do all the states, but I can't get Iowa to light up. And I said, well, pronounce the word hour, H-O-U-R, the way you pronounce it in Australian, and Iowa will light up. You
oh,
know,
how
it was
funny.
just say Iowa, you know,
Right.
that, and then Iowa would light up. David also asked me, do I have to go into the office in Colorado? I do everything from home. Yes, I do. I work from home, and I've been telecommuting pretty steadily on and off, but mostly steadily since 1987. Okay, I got involved very early. I was on Unix systems.
What?
I was on Unix systems, so I was able to, transfer files by FTP. And
Yeah.
so I was more productive at home. So I would go in for meetings and then I'd work from home. So since 1987, I've been largely telecommuting. I telecommuted quite a bit. I was one of the early telecommuters when I was contracting at IBM. Um,
Hmm.
and uh, because I knew how to do it and I kept up my productivity.
Right.
Uh, quick advice for young people: all you've got is your skill set and your reputation for integrity. Don't ever damage any of them, either of them. Keep improving your skill set, keep your reputation for integrity, never screw an employer, because you don't have any stock in trade except your character and your ability. That's all you have if you want to be in this business. And the other thing is watch your health. We sit too much. We programmers sit too
Mm,
much, and over the decades, it will begin to affect you.
yeah.
And you have to be sure you get up from the computer and exercise, and do not let the computer destroy your health. So that's a little piece of gratuitous information that Tish didn't ask for, but I like to say that to young people.
No, this is good information because my next question was how do you relax? And how do you rejuvenate yourself? Because it's very important. Because there's a lot of folks, people just get up and then we don't see them anymore and then you find out it's because, they weren't moving, they weren't mobile, you know, their cholesterol, that piece of the cholesterol that is too high because they had been sitting for so long, they haven't had any, activity is bad or whatever. And it's because they've been sitting at their computer forever and ever and ever.
Well, in the winter I shovel a lot of snow. In the
Yeah.
summer I don't have a power mower. I scythe and I push
Do
a
you
hand mower.
really?
I
Really?
scythe. I've got an acre and I scythe it. And I, get up and do housework. We've got a combined house and pottery studio and gallery for my wife, and I, clean the gallery. I sweep a lot and stuff, and I go outside and trim down the weeds. And in the winter, I shovel snow, and in the fall, I get a lot of exercise turning around and going the other way when the bears show up on the street. So,
Well, if
yeah,
you're
you
out
go that
hunting
way, I
bears,
go this way.
well, let me ask you this then: how do you all keep the pottery dust from out of the air? Because pottery dust is brutal. How do you keep it out of the air?
Well, the studio is the studio. And that, we bought we have a live workspace. We have a former commercial property
Oh,
that
okay.
had 5 units. So the studio is the studio, the kiln shed is the kiln shed, the gallery is the gallery, and our living space, and my office is my office, and the living space is the living space.
Right.
And we have air particulate absorbers with filters in every room.
Okay.
I mean, and they're on all the time. It is a problem. And and the wife sometimes has to close the door and work with respirators when you sand pottery to finish it. She's wearing a full respirator.
Okay.
And she keeps the doors closed and lets the air purifiers take the dust out of the air before she opens the doors again. So it is very, again, that's another thing you have to be very careful about. You have to watch your health, because you can't do any kind of work if you lose your health for your work.
Right. But she's like a professional. Like she's like a real true blue artist. So I mean, I know that
career artist, professional, degreed artist. Molar chemistry was part of the training and stuff like that. So she's a scientist and a potter, and she taught for 22 years at the city of Lakewood.
Yeah.
And then we opened our own gallery. So yes, it's very serious stuff. And she's a production potter, and she's producing quite a bit of it. So and she's very popular and well known within that field, and has given workshops internationally.
Yeah, we love her. We are going to. Do you have any other gems of wisdom that you can drop on us within these last 2 minutes?
Yeah, well, a fellow I used to play with in a group for many years, Moses Walker of the Clam Daddies, and we played in the worst dive bars of the Four Corners area, Utah, Wyoming, Colorado, and he'd always sit up there and growl at the audience and say, "If it ain't fun, don't do it," and keep having fun. This is a very interesting field. It's very rewarding, and it's funny, and it's about people. There are no technological problems in our field. There's just people problems. We've got all the technology we need, and then some. We've got a lot of technology we don't need. You will never have any trouble finding technology to solve the problems that you're trying to solve. Amateurs can build moon rockets nowadays. We're planning to go to Mars. There's all the technology you can use, and much more than you can ever use. The important thing is that everything you do at work, taking this down, everything you do at work, every problem you have to solve turns out to be a people problem. You have to get people to agree how we're going to do this, how we're going to pay for it, when we're going to do it, what the time schedule is going to be, what it's going to look like. Right. So hone your people skills. Don't just think because you're a tech person that you can prescribe for the world. It was a lesson that took me quite a bit of time to learn, so I can understand if it's a difficult lesson, but it's about people. The machines will take care of themselves. They'll be running by themselves long after we're gone.
Right. Long after the checkout.
Okay. Good luck with your career in data science and quantum computing. It'll be mainstream before you retire. Believe me. Watch quantum computing. That's the next thing. Yes. Love your work, and it's more like fun than work, David says, and I agree with that. Absolutely.
And you had said that you wanted to make quantum boring, and I love that.
Yeah, right. It's just another technology.
I hope that you label that and put it on a shirt, because I definitely will buy it. You know what, Jack? You are one of my favorite, and I have said this maybe twice on my show. You will be the third. You are one of my favorite people to watch. Hands down. And when I met you finally in person, I was so nervous. I was so giddy, all on the inside. And you sat right next to me in the auditorium, and we were doing sound check. And I was just like, oh my gosh, I can't believe I'm sitting right next to Jack Ward.
And I was thinking, I can't believe I'm sitting next to 𝗪𝗏 𝗪𝗏. So. It's such a great show, you know what I mean? It's like knowing a celebrity.
Oh,
to know you. So.
No, your contributions and just knowing the career, it's so inspirational, and we all can do it. Thank you.
We can all do it together. Thank you very much, 𝗪𝗏.
I'm gonna take that, and I'm gonna live on that for like at least 2 weeks, at least bare minimum.
Well, I'm on cloud 9 now, haven't had a chat with you.
Thank you, so. And please say hello to your lovely wife, and Thank you so much for being with us. And I'll just go ahead and close out the show. Um, thank you everybody for coming on and staying with us and being a part of this journey with us. Jack is truly sensational and such a wonderful technologist. I'll have the links to his teaching on every month and in the description. So don't worry about that. I got you covered. I will see you soon. Thank you, Jack. And
Thank
you
you,
guys have a
Letitia.
great day. All right. And thanks for joining Tish Tech.